Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 3, Lesson 3 on fractions and algebra. Now this entire unit is really about ratios and proportions and things that you've kind of had a little bit of exposure to in the past. Algebra and some very simple algebraic equation solving techniques are very helpful in this unit. Now we're going to do some more algebra later on in the course. I know that we haven't hit it yet, but today what we're going to do is we're going to review some very basic algebraic ideas to give you some tools, just some tools in your tool chest that will make this unit and the next unit on percent a lot easier to deal with. So let's get into it in exercise 1 where we review a little basic algebra. All right, a review of some simple one-step equations, exercise number 1. Solve each of the following basic equations. Check your answers. All right, so remember, solving an equation is all about finding the value of a variable to make the equation true. Now, many of these equations, you could figure that out by just sort of looking at them. I get that, but all right, make sure that you follow along with the technique as well. Now these are all what we call one-step equations, meaning that all you have to do is a single step in order to isolate the variable, to get it all by itself. So for example, in letter A, I have 3 times x is equal to 15. In order to get 3 by itself, what I want to do is undo that multiplication by 3, and I do that by dividing by 3. Right? It's really that simple. I divide both sides by 3, and we can really think about this as 3 divided by 3 equals 1, and I don't need to put down 1x. That's kind of what it implies. And then 15 divided by 3 is simply 5. Okay? Both letter B and letter C are very similar, so why don't you pause the video really quickly. Now I know letter C involves a negative, so keep in mind rules about, multiplying and dividing negatives. And I think you'll be able to figure out both C, B, and C. Go ahead and pause the video now. All right, B might be the most challenging. I have -8 times C is equal to 24. So what I'm going to do is I'm going to divide both sides by a negative. -8 divided by -8 is equal to 1. And positive 24 divided by -8, remember, a positive divided by a negative is a negative. And in this case, we'll have -3. All right, letter C, same idea. I have 4 times y is equal to 48. In order to isolate the y, I'm going to divide both sides by 4. 4 divided by 4 is equal to 1, and our mysterious red pen makes a visit. 48 divided by 4 is equal to 12. All right, no idea, it just comes out of nowhere. Let's take a look now at other types of one-step equations. So in those first 3 one-step equations, what we did is we divided both sides of the equation in order to undo a multiplication that had occurred to the variable. All right? In D, E, and F, what we're going to do is we're going to go in the other direction. So for example, in letter D, we have x divided by 7 is equal to 4. Right? What I want to do is get x all by itself, so I'm going to multiply now both sides of the equation by 7 to undo that division by 7. I'm going to rewrite the equation down here just so I have a little bit more room to kind of work with. All right? And literally at this point what I'm doing is I'm just multiplying both sides by 7. If you want to think about it as these 7's canceling, that's fine. And then I get 4 times 7, which is 28. Now, letter E and letter F might look a little bit more daunting because you've kind of got fractions on both sides. But really, this side of the equation is not so important. When we look at this side, we've got y divided by 10. In order to get y all by itself, I now need to multiply this side of the equation by 10. Right? I want to undo that division by 10. And on this side of the equation, I'll also multiply by 10. What I do to one side of the equation, I must do to the other side of the equation. All right, now 3 halves times 10, that's simple enough, right? I can cross cancel. 3 times 5 gives me 15. All right. Why don't you really quickly do letter F? All right, let's go through it. So we've got d divided by 12 is equal to 3/4. What I want to do is I want to multiply by 12 on both sides. Okay, so I'll get the 12 times d divided by 12 is that equal to 3/4 times 12? Cancel. 3/4 times 12, 4 goes into 12 3 times. 3 times 3 gives me d equals 9. Now, really, in all three of these cases, but more importantly, in E and F, if we took those values and we substitute them back in, what we would have is simply an equivalent fraction statement. In other words, in this problem, we'd have 15/10 is equal to 3/2, right? Those two are equivalent fractions. Over here, we'd have 9/12 is equal to 3/4. Again, equivalent fractions. And really, what we're really getting at is fraction algebra, the algebra of fractions. So let's take a look at that idea a little bit more. One of the important things in sort of what we're going to be doing today is the idea of having two fractions that are equal to each other. The question is, how would we know if two fractions were equal to each other if they were set equal and we just wanted to test it, right? So let's take a look at exercise number 2. Consider the two equal fractions 3/4 and 6/8. Letter A asks us to convert each of the fractions to decimal form using long division to show that they are equal, right? Now, you probably are well aware that these two fractions are equal, but one way that you can actually show that they're equal is by creating the decimal form of both fractions and seeing that it's the same. So let's use long division and actually go through 3/4 or 3 divided by 4, and then we'll have you do 6/8 or 6 divided by 8 on your own. So if we, this is basically just getting back to how do we convert a fraction into a decimal. So 3 divided by 4, right? 4 doesn't go into 3 at all. So we would get something like that. 4 then goes into 30 7 times, which would give me 28. Subtract 2. I'll drop another 0 down. 4 goes into 25 times. That's a 20. Subtract, and I get 0. So 3/4 is equal to 0.75. All right, what I'd like you to do is the same thing here. Pause the video now and do the long division to get the fraction form of 6/8. Now, the whole point is that it really better should turn out to be 0.75, or I've made a huge mistake with this particular exercise. Here we go. So I want to do 6 divided by 8 because that's what this fraction means. So I'm going to write it as 6.0 divided by 8. 8 goes into 6 0 times. When I do the subtraction, I'll be left with a 6. I'm going to put my decimal point up here, drop my 0 down. 8 goes into 60 7 times. That gives me 56. I'm going to subtract, get me 4. I've got to drop that next 0 down. 8 goes into 40 5 times. I get 40, subtract 0, and there it is. So 6/8 equals 0.75. Now you might ask, why did I do that? Well, number one, I wanted to review the process of converting a fraction into a decimal. It's very important. It's part of the 7th grade math standards, right? This idea of being able to see the equivalence between a fraction and its decimal form. But I also wanted it to be so that you knew 3/4 and 6/8 were equal and unequivocally equal. Now in letter B, it says, find the cross products of the circled numbers below. What's true about them? All right, in other words, what is true about 3 times 8 versus 4 times 6? Pause the video and think about that for a moment. Well, if you actually do the cross products, 4 times 6 is equal to 24, and 3 times 8 is equal to 24. So what you should note is that they are equal. And that brings us to a very fundamental idea about fractions, which is when two fractions are equal, their cross products will be equal. All right? So when two fractions are equal, their cross products will be equal. In other words, if you take the numerator of one fraction and multiply it by the denominator of the other fraction, it will then work as the denominator of this fraction times the numerator of that fraction. It's a fantastic thing about equal fractions. And likewise, if their products are not equal, then the fractions themselves are not equal. So let's take a look and apply this in exercise number 3. Determine if each of the following statements of equality is true or false by comparing cross products. All right, so simple enough. In other words, is 4/3 equal to 12/9? Well, one way to do that is by simply saying, well, if I take 4 times 9, I get 36, and if I take 3 times 12, I get 36, and so the answer is yes. They are equal fractions. What I'd like you to do is use that cross product test in letter B and letter C to see if those equality statements are true. All right, let's take a look. Let's do maybe the easy one first here. 7 times 10, well, that's going to be 70. And 5 times 12, that's going to be 60. And so the answer is no. All right. I wasn't too original in letter C, sorry about that. But in this case, right, if I do 4 times 9, I'll get 36. If I do 6 times 6, 36 is just such a nice number. I also get 36. So yes, those two fractions are equal. There it is. And it's a fantastic test. You know, if you're ever just wondering, are two fractions equivalent? This is a good test. But we don't really want this test in and of itself. We don't want it for this. We're not going to really be asking a question too often about, well, are these two fractions equal? No, in fact, we want it because it gives rise to something called cross multiplication. You see, what's tough about solving equations that involve fractions is only one thing. There's only one thing that's difficult at all about equations that involve fractions, and here's what it is. They have fractions in them. That's it, right? And that does make them difficult because, quite frankly, fractions can be confusing. 4 out of 3 people say that fractions are confusing. It's that simple. So let's take a look at exercise number 4 and see how we can use cross multiplication to take an equation that has fractions in it and rewrite it so that it doesn't. Exercise number 4. Use cross multiplication to rewrite each of the following equations so they do not contain any fractions. Then solve the equations. So the whole idea of an equation is you want to find the values of the variables that make the equation true. So we go in with the premise that this is a true equation, because if we start with the idea that it's a false equation, well then we're in trouble. If it's a true equation, if this fraction is equal to this fraction, then the cross products should be equal. In other words, 12 times x, which I'm just going to write as 12x, right, must be equal to 4 times 9. I'm going to use the parentheses method of showing multiplication here. At that point, right, I now have an equation, thankfully, that has no fractions in it. Not only does it have no fractions in it, I have a one-step equation, right? 12 times x equals 36. In order to solve it, just like we did in exercise number 1, a, b, and c, I'm going to divide both sides of this equation by 12. And 36 divided by 12 is equal to 3. Cross multiplication is one of the most important equation solving techniques in all of algebra. We're going to be using it extensively in this course because we're going to be doing a lot of work with ratios, and ratios involve fractions, etc., etc. So this is an amazingly great technique because you can take an equation like this one, 5 divided by c equals 20 divided by 8, and you can easily now solve for c. Right? You can just say, well, I'm going to do 20 times c is equal to 5 times 8. Whoops. That's the other part of the butterfly here. 5 times 8 is equal to 40. And now I just need to divide both sides by 20. And 40 divided by 20, we're all comfortable with, should be 2. All right. Why don't you use this technique to solve the equation in letter C? Now, I would like to point out that both A and C were problems like we solved in exercise number 1, right? In exercise number 1, especially D, E, and F, we were solving equations that looked an awful lot like A and C. So there are other ways to solve this equation. We're just working on this particular technique, which is to take a fraction, or an equation, sorry, where we have a fraction equal to a fraction and write it with no fractions. So here we go. I'm going to do 10 times y is equal to 5 times 14. Now, the one thing that's maybe a little bit of a downside of this technique is you actually have to always sort of do this multiplication. But 5 times 14 is 70. That's not too bad. And then I'm going to divide by 10. And y is equal to 7. All right, it's a fantastic technique. Two equations equal to each other, suddenly you no longer have, two fractions equal to each other, suddenly you no longer have fractions. Let's keep running with this. One more problem. Now, in the last set of examples, it would have actually been relatively easy. In fact, let me just go back there for a second. It would have been relatively easy in each one of these cases to just sort of look at this as a situation of equal fractions, right? To look at something like this where I've got a fraction of 9/12 and something fourths, and just think about, well, what fraction with a denominator of 4 is equivalent to 9/12? Same thing here, I could still do it. I could do just kind of a scaling issue in terms of ratios. Oh, well, 5 times 4 is 20, so 8 divided by 4 is 2, right? All of these, that would be relatively easy to do because we really are just kind of like scaling up or scaling down the fraction, right? We really don't need to use this technique. But this technique is particularly powerful when the variable that you're solving for isn't necessarily a whole number. So let's take a look at exercise number 5. Consider the equation 6 over x equals 15 over 2. Letter A, solve this equation by using the method of cross multiplication to remove the fractions. All right, well, we just worked on this technique for a little bit. Why don't you go ahead and do it? I will warn you that letter A, you'll end up getting a fraction as an answer. Write your answer in simplest form. Pause the video now. All right, let's do it. So in this case, right, when we do the cross multiplication, we'll get 15 times x, which is just 15x, and then we'll get 2 times 6, which you can certainly just write immediately as 12, and I almost just did that. Or, if you've got to write this out first, that's fine, right? I then divide both sides by 15, and I get a fraction. I get 12/15. Now that fraction can be simplified quite extensively by dividing both the numerator and the denominator by 3. Right? That's easy enough. And what I find is that x ends up being 4/5. Now that would be a very difficult one to kind of just look at and go, oh, how do I scale this fraction to get that fraction? Quite challenging to figure out 4/5, right? Now letter B says check your solution to A by substituting it into the original equation. Right? Let's do this together. Remember, we should always really be able to check our solutions to equations by simply taking the answer, putting it back into the original equation, and seeing, does the left-hand side of the equation equal the right-hand side? So truly, the question here is, if I put 4/5 back into this equation, is it true? Right? Right? Is that a true equation? Now, in order to deal with that, I think I'm just going to leave the 15/2 alone, and I'm going to try to simplify this. And this really is a complex fraction. It's 6 divided by 4/5. So I'm going to change that around into 6 times 5/4. Now, if you really like the multiplication algorithm for fractions, you might want to write that 6 as 6 over 1. But now I could do a little cross-canceling if I wanted, right? I can make that into a 3, I can make that into a 2. And now I have 3 times 5, which is 15, 1 times 2, which is 2, and there it is. So yeah, it checks, right? And it's always a good thing to remind ourselves that we can check solutions that we get to equations by putting them back into the original equation to see if it makes it true. All right, let's wrap this thing up. Today, we just reviewed some basic ideas about how you solve equations that involve fractions. And we introduced a very powerful technique for solving those kind of equations called cross multiplication. When we have a fraction equal to a fraction, we can cross multiply to produce an equation that has no fractions in it whatsoever. And if you don't particularly like fractions, That's a great thing, right? In terms of a technique that allows you to get rid of them from an equation. All right, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.